To solve problem 5 from lesson 5.3, we need to look at two of the conjectures that we learned today. The first is the kite diagonals conjecture, which says that the diagonals of a kite, these two, are perpendicular. In other words, meet at 90 degrees. The second conjecture that we will need today is the kite angle bisector conjecture. This conjecture says that the vertex angles of a kite are bisected by the diagonal. So let's look at what that means. The vertex angle is between two congruent sides. So this would be a vertex angle. It says it's bisected by the diagonal, so the two parts on this side and this side are congruent. And the same is true with this angle. It is also bisected. Let's look at how we use these two conjectures to solve problem number 5 on. For problem number 5, the first thing we're going to look at is the fact that the diagonals meet at 90 degrees or are perpendicular. That means that in the center here, I have four 90-degree angles. That allows me to find some of the missing parts. For instance, if I look at this triangle on top, I know that in that triangle I have an 18-degree and a 90-degree angle. So if I add those two together and then subtract that from 180, that gives me the measure of this angle right there. And I think I'm going to make this a little bigger so we can kind of see what we're doing in here. This angle right here will be 72 degrees. The next conjecture says that the vertex angles are bisected by a diagonal. So if this side is 72, so is this side, meaning that x must be 72 degrees. Take a look at y. We will use the same reasoning for y. The vertex diagonal bisects this angle. So if the right-hand side is 29, so is the left-hand side. The angle in the upper right-hand corner of this triangle is 90 degrees. You can use the 29 and the 90 to find the measure of angle y.